Hey everyone, welcome back to Mind Maths with Amna. Today I'm going to talk about how we move from the pre-New Keynesian dynamic ISLM to the new Keynesian DSGE model. Okay, so in the pre-NK model, we had an IS curve which we derived from the goods market. We had an LM curve derived from the money market, and we discussed two possibilities that either the central bank could have monetary targets or inflation targets. And the third equation was the price adjustment equation. We then converted the system into a 3 by 3 matrix form, and then we analyzed the short run and long run dynamics. Okay, so what happens in the new Keynesian framework? So let's discuss that. So in the new Keynesian framework, we're more interested now in the deviations of output from its steady state. Okay, so what we do is that we defined a variable xt, and we say that it is log of yt minus log of y bar, which is basically just the deviation from the steady state. And in some texts you will find small y minus small y, n, which denotes the natural level of output. Okay, so basically now the IS curve in this framework shows deviations from the steady state. Okay, and how do we derive this curve? I'm just going to call it the ISNK, or you can call it the new Keynesian IS curve. Basically, it comes from the Euler equation. Subscriber told me. I still keep on saying Euler's. It's Euler's equation, which we get from intertemporal consumption optimization. It is actually an infinite horizon dynamic problem, which we will solve in the next lesson. And it also includes expectations. And this is what it looks like. So don't worry about how we got to this conclusion, because that's going to be in the next recording. So xt, which is deviations from the natural, is equal to the expected level of future output deviation, 1 over delta into RT minus RNT. This is known actually, there are other forms of the IS curve in the new Keynesian model. This is just known as the canonical. What should we call it? Canonical IS curve in the NKDSGE model. Remember y bar, which is the natural rate of output, it's explicit, and Rn is just the natural rate of interest rate. Okay. And what this tells us is that whenever the interest rate is above the natural, there's going to be, basically, we know the dynamic that is investment is going to fall, which is going to lead to a fall in output, and therefore y will fall below its natural state, and therefore the output gap is going to be negative. Okay. Another thing to remember is that the real interest rate is equals to the nominal interest rate minus the expected inflation rate, and this was derived by the equation 1 plus RT is equals to 1 plus IT over expectations of inflation, and this was derived from the no arbitrage condition. So from this box on the right, we applied logs and ended up at the Fisher equation. Okay, so we've already talked about the IS curve. What happens to the LM curve? Okay, so this was point number 1, because and point number 2 was what happens to the LM curve. So in this framework, we're going to replace the LM curve with a Taylor rule, or you could call it the monetary policy response function. So the LM curve now gets completely replaced, and the Taylor rule can be written like this: the interest rate is equals to the natural plus the coefficient of inflation into inflation plus coefficient of output gap into the output gap. So central bank sets the interest rate, and the money supply adjusts automatically. Okay, so what about the last equation? So in the previous pre-K model, we had a price adjustment curve, right? So we need to replace that as well. So we replace the price adjustment equation with the new Keynesian Phillips curve. And obviously there's going to be, like, the derivation is supposed to be done separately, so there's going to be a whole other lecture on how the IS curve gets derived. And we don't need a lecture about the Taylor rule, because we don't need a derivation, it's just a rule, but we will need to derive the Phillips curve as well. And with these 3 equations, we do then end up with a 3-equation new Keynesian model, DSGE model, in which then we can, see things like what happens to output and interest rate after monetary innovation shock, or shock in government spending, or productivity shock. So we can see all those things once we have the model in place. Okay, next, the new Keynesian Phillips curve looks like this: delta xt, and this is basically backward looking, and the gap is based. It is gap based because this is a gap, right? And it has no expectations. But recently there has been Phillips curve upgrade, and in some questions you might find the Phillips curve being written as current inflation is equals to beta into expected inflation in the future period. So it becomes forward looking, and some constant k multiplied by the output deviation. Okay, so let's before concluding, let's do, like, juxtapose these 2 things and compare. So there was a pre-New Keynesian framework, and now we have a new Keynesian framework. This had the IS curve, which was stated in levels. Okay, and in this in the new Keynesian, the IS curve is stated in terms of output gap from the natural. Okay, in the pre-K, pre-NK, we had an LM curve, LM equation. Over here we have what we call the Taylor rule, or the monetary policy response function. And then we had, in the pre-K, we had the Walrasian inflation, which basically is the price adjustment curve. And over here we have the new Keynesian Phillips curve. Okay, so what else? In the pre-NK model, we had no expectations. There was no expectations in that model, and in this we do have forward looking behavior. So we do have expectations here. In the pre-NK, prices used to adjust, but now this new Keynesian model is actually micro-founded, and it has sticky prices. Okay, but overall, like in the overall scheme of things, they talk about somewhat the same thing. For instance, in the pre-NK, if there was a shock, then output would deviate from the natural, and it would, for instance, a positive shock would lead to a rise in inflation, and real balances would, as a result, fall. And when real balances fell, output would eventually, in the long run, return to the natural. In the new Keynesian framework, a shock would basically lead to a deviation in the output, right? So we'll say that xt is no longer equals to a zero. That again is going to be inflationary, and that's through the Taylor rule. Interest rate is going to rise through the Taylor rule. A rise in the interest rate basically leads to contraction of demand, and therefore x falls, converges back to zero. So the difference, the gap begins to dissipate. So this was just an introduction. So you see that you have this thing in your brain that there was a pre-new Keynesian framework, and now we're transitioning into a new Keynesian DSGE model. And it's interesting because it's going to have three equations: 1, 2, 3, and this we have the IS curve, new Keynesian IS curve, and we have the Taylor rule, and we have the Phillips curve in the new Keynesian model, and we're going to derive each of these in separate lessons. And then once we have the 3x3 model, we can basically generate impulse response functions and see what happens when there are any kind of shocks in the economy. I hope this introductory lesson was beneficial, and I will see you in the next one. Take care.